Thank you for joining us for another installment of Streivor's DemandAire Control System tutorial. This video will cover the operation, wiring, and troubleshooting of Streivor's DemandAire Gold. The DemandAire Gold Control Panel can be added to Type 1 hood systems, with associated UL300 listed fire suppression systems, to facilitate the sequence of operation required by the mechanical, electrical, and fire suppression codes. The control panel houses electrical terminals to provide electrical connections to the hood system accessories, such as the exhaust hood's lighting, internal hood fans, if included, hood resistance temperature detectors, kitchen resistance temperature detector, human-machine interface enclosure and touch screen, exhaust and supply fans, and the hood's fire suppression system accessories. Consider these safety advisories when performing tasks on a hood system and the DemandAire Gold Control Panel. Ensure all work is performed by qualified contractors. Ensure that all power from the source to the control panel is shut off, locked out, and tagged out. Verify that the serial number on the control panel matches with the serial number from the wiring diagram or drawing. Confirm that the power's voltage, wire's amperage capacity, and wire insulation are in accordance with the fan motor's nameplate. Reference the Streivor DemandAire drawing, labeled DA, to obtain installation details from the hood schedule, electrical schedule, and electrical rough-in schedule. Identify the location and mounting method that were specified for the control panel by reviewing the drawing's design plan. If your control panel is mounted in the utility cabinet, it will be pre-wired at the factory to its accompanying hood electrical accessories. For control panels mounted remotely, the electrical wiring for the appropriate hood accessories will need to be connected to the control panel. Follow the DCP detail from the DA drawing to determine where the control panel needs to be surface mounted, and also the location of the HMI enclosure, along with the proposed height that it should be installed at. Keep in mind that 36 inch of access clearance is always needed in front of the HMI enclosure. The design plan conveniently shows the location of the applicable items, and the rough-in requirements section determines how electrical wiring should be brought to the control panel. Now that you have an overview of the system, proceed to the control panel's wiring diagram for details on inputs and outputs that the accessory should be connected to. Take a moment to identify the connections and the terminal blocks associated with each accessory. For additional clarity, each connection is labeled with the required electrical voltage on the DemandAire drawing. To supply power to the control panel, start by verifying that the circuit breaker voltage, phase, and amperage powering the control panel matches the requirements shown on the DA drawings and the label located inside the control panel. After verifying the circuit breaker is the correct voltage, phase, and amperage, proceed to connect the 120 VAC single-phase power to the designated terminal blocks in the control panel. When and if applicable, external accessory inputs to the control panel may be included. Some of those external accessories may include standalone rack ovens or PCU wash and dry cycle signals. Connect the designated terminal blocks in the control panel to the appropriate external destination. To supply power to the hood lights, wire terminal block 11 hot, terminal block 12 neutral, and ground to the corresponding wires in the junction box labeled E1 on the hood. If the HMI is controlling the hood lights on multiple hoods, locate the E1 junction boxes for each additional hood and daisy chain them together. To supply power to the HMI touch screen, wire terminal block 121 from the control panel to terminal block 123 in the HMI enclosure panel. Wire terminal block 120 from the control panel to terminal block 122 in the HMI enclosure panel. And ground. Connect a Cat5 Ethernet communication cable from the control panel to the Ethernet port on the HMI. The control panel is engineered to comply with NFPA 96 Section 10.4.1. If the fire suppression system is provided by Streivor, the control panel will provide terminal blocks with 120 VAC single-phase power to be connected to a normally closed dry contact interlocked with the FSS activation to be provided as part of the FSS. The control panel will provide the electrical functionality for the fire suppression accessories such as normally open 120 VAC signal for electrical shunting, etc. When the fire suppression system is activated, the control panel will simultaneously shunt power to the hood lights, internal hood fans, electric gas valve if applicable, interrupt the associated supply fan control signals, start the associated exhaust fan control signals at 100%, and apply 120 VAC power to the normally open shunt terminals. Streivor's fire suppression systems will include 3 electrical switches and 1 alarm switch, sometimes referred to as microswitches. The electrical switch is rated for 250 VAC single-pole double-throw switch that facilitates turning on or off devices that are required during the system activation. The alarm switch is rated for 28 VDC and includes screw lugs to be used to close a supervised circuit connected to the building's fire alarm system. To begin wiring, locate an FSS electrical switch located in the FSS control head. Wire terminal block 70 to the common leg of the FSS electrical switch. Wire terminal block 71 to the normally open leg of the FSS electrical switch. Wire terminal block 72 to the normally closed leg of the FSS electrical switch. Terminal block 71 can be used to provide power to a shunt trip device to comply with NFPA 96 Section 10.4.1. Terminal block 71 should provide 120 VAC power upon fire suppression system activation. The building alarm circuit is to be connected to the alarm switch with lugs. If the fire suppression system is not provided by Streivor, the control panel will provide terminal blocks with 120 VAC single-phase power to be connected to a normally closed dry contact interlocked with the FSS activation to be provided as part of the FSS. The control panel will not provide the electrical functionality for the fire suppression accessories, such as the gas shut-off valves, reset relays, shunt trip signals to the breakers, etc. When the fire suppression system is activated, the control panel will simultaneously shunt power to the hood lights, internal hood fans, interrupt the associated supply fan control signals, start the associated exhaust fan control signals at 100%, and apply 120 VAC power to the normally open shunt terminals. To supply power to your internal hood fans IHF, if applicable, wire terminal block 3 hot, terminal block 4 neutral, and ground in the control panel to the wires in the junction box labeled E2 on the hood. If the control panel is controlling the IHF on multiple hoods, locate the E2 junction boxes for each additional hoods and daisy chain them together. Internal hood fan power to terminal blocks 3 and 4 will be automatically shunt during a fire suppression system activation to comply with NFPA 96 Section 8.3.2. Refer to the DemandAire drawings to verify the installation location for the kitchen resistance temperature detector, KRTD. If the KRTD is located on the utility cabinet or the control panel, it will be pre-wired in the factory. No field connections are required. If the KRTD is mounted on the HMI enclosure, connect the terminal blocks labeled T0 in the control panel to the KRTD. Streivor recommends using UL-listed 22-gauge 3-stranded shielded cable. The KRTD should be installed away from direct sunlight, makeup air diffuser airstreams, and other sources of heated or cooled air. To supply power to the hood resistance temperature detectors, HRTDs, connect the terminal blocks labeled T1, T2, etc. in the control panel to the junction box labeled E3 on the hood, using the UL-listed 22-gauge 3-strand shielded communication cable. Check the drawing for the specific quantity. If the control panel is controlling the HRTDs on multiple hoods, locate the E3 junction boxes for each additional hood and provide a dedicated run for each HRTD. To supply input power to the gas valve if applicable, connect the 120 VAC single-phase power to the designated terminal blocks in the control panel labeled H1, N1, and ground. To supply output power to the electric gas valve, connect the designated terminal blocks in the control panel labeled 130, 131, and ground to the electric gas valve. Repeat this process for additional electric gas shutoff valve circuits if applicable. Connect the terminal blocks in the control panel, designated for fan control signals, and run signal dry contacts to the appropriate external destination. DemandAire systems may include a manual reset relay for the electric gas valve. The current status of the reset relay is displayed on the top left corner of the HMI screen. In the event of a fire suppression system actuation or any power interruption to the control panel, an alert symbol will appear on the home screen. To reset the relay associated with the electric gas shutoff valve, press the arrow to view the alarm log screen. Select the gas valve power off alarm on the alarm log screen. Press the More Info button to proceed. Follow the on-screen instructions to manually reset the electric gas valve. Before troubleshooting, test any ground and neutral shorts. Verify that the control panel has 120 VAC power and verify you have power going out. If your fans are not turning on, check that the wiring is connected and that there is continuity at the dry contact for each applicable fan, while the fan button is pressed on the HMI touchscreen. If not, see your DA drawings to verify the dry contacts are wired correctly. Check the control signals are terminated at the appropriate external destination and verify the signals are being received. If those components are working as intended, then contact the respective manufacturers of the other components of the fan motor power circuit for troubleshooting those items, such as the VFD. If your internal hood fans or hood lights are not turning on, verify that the FSS control head is in the armed position. Check outgoing power to the internal hood fans in terminals 3 and 4, or 11 and 12 for hood lights. Check that there is continuity between terminals 70 and 72. Check that there is not continuity between terminals 70 and 71. Check that the FSS electrical switch is wired correctly. For projects with multiple hoods, check the interconnecting wiring between the hoods at the pre-wired junction boxes on top of the hoods. If the hood lights or internal hood fans are receiving power and they are still not operable, replace the inoperable item. If your exhaust fan does not turn off, verify that the FSS control head is in the armed position. Check for any alarm screens displayed on the touch screen. Check that there is continuity between terminal 70 and 72. Check that there is not continuity between terminal 70 and 71. Check that the FSS electrical switch is wired correctly. The HRTDs located in each hood are engineered to automatically turn on the fans controlled by the DemandAire system once the adjustable set point of at least one HRTD has been reached. Each HRTD has an adjustable temperature differential set point. The set points have been preset by the factory. However, depending on field conditions and cooking appliances below the hood, further adjustments may be necessary. The recommended temperature differential set point is approximately 5 degrees to 15 degrees Fahrenheit above the ambient temperature in the kitchen. Access the temperature differential setting screen to make these adjustments. If an alert appears on the HMI home screen, press on the arrow to access the alarm log to see what alert you received. The alarm log displays each alert occurrence, description, resolution, and acknowledgement. In the event of a temperature detector alarm, this indicates that a hood resistance temperature detector is not functioning properly due to damage or incomplete wiring. The exhaust and supply fans will automatically go to full capacity upon sensing an HRTD alarm. Once the alarm has been resolved, select the TS alarm using the up and down buttons. Press the Acknowledge button and resume normal operation. In the event of a high temperature detector alarm, this alarm indicates that the temperature detector in the hood is reading a temperature above the high temperature set point. Immediate steps may need to be taken to reduce the temperature in the hood or to prevent an uncalled for fire suppression system activation. Some steps that may need to be taken are: verify that the hood exhaust fan is operating as designed. Verify that the cooking appliances under the hood are working as designed. The factory recommends 300 degrees Fahrenheit as a typical default setting. If this temperature setting is not optimal for your cooking conditions, you may contact Streivor for recommendations on adjusting the high temperature set point. Once the hood temperature decreases below the high temperature alarm set point, select the high temp alarm using the up and down buttons. Press the Acknowledge button and resume normal operation. If your HMI screen isn't lighting up, verify it's receiving the 24 VDC power. If power is being received, contact Streivor. At Streivor Air Systems, we consider customer service and quality assurance a top priority. For any additional support, please email our team at info@streivor.com, and thank you for helping Streivor strive for excellence.